negative 3 up to 0 of 1 plus the square root of 9 minus x squared dx. And our job is to evaluate the integral by interpreting it in terms of area. Okay, so here we have this integral, the integral from negative 3 up to 0 of 1 plus the square root of 9 minus x squared dx. So, Erin, what were your first thoughts when you looked at this?
Well, I kind of had been doing, like, using the midpoint formula, kind of, and doing it numerically.
Okay.
But then it seemed like they might have drawn the picture and then done it in steps, kind of like you just did with the last one.
Okay, good. So when the instructions are saying interpret in terms of areas, and they're actually using the word evaluate the integral as opposed to approximate the integral, avoid using those rectangles unless they say find an approximation. So if they say evaluate, that means find an exact value. So let's take a look at what this function is. So what we want to look at, and let's call this f of x. So f of x is equal to 1 plus the square root of 9 minus x squared.
So in doing this problem, they would expect you to use your calculator, wouldn't they?
In this?
Well, to just see the form of the function, or
well, that's a good question. So when I look at this at first, I'm like, wow, that's a pretty complicated function. What the heck does this even look like?
Right.
So here's what we want to think about. So you might go to your calculator and you might say, okay, let me draw a picture of this.
Right.
But what I'm going to recommend is that we kind of analyze this thing a little bit more.
Right.
So I'm going to forget about the 1 plus for now. And let's just look at y is equal to the square root of 9 minus x squared. Now, if I want to know what this looks like, well, this form is not very nice, but if I square both sides, then I have y squared is equal to 9 minus x squared. And if I rewrite this in a slightly different way, if I move that x squared over, then I've got x squared plus y squared is equal to 9.
It's a circle.
Yeah, so this is a circle with radius 9, or I'm sorry, radius 3. And this circle is centered at the origin. So a picture of this one, of x squared plus y squared equals 9, looks something like this. Now, the thing about this picture here is that originally we started with y is equal to the positive square root of 9 minus x squared. So, in fact, if I'd started with x squared plus y squared equals 9 and I solved for y, then I would have a plus or minus square root on there. So, because this only has the positive square root, it tells us that we're only looking at the top half of this circle. So the top half of this circle is y is equal to the square root of 9 minus x squared. The bottom half of this circle would be described by y is equal to negative square root of 9 minus x squared. So we are interested in the top half of the circle. So right now we've got this blue curve up here. That's y equals square root of 9 minus x squared. Now if I take that and I add 1 onto it, what does it do to that blue curve? Yeah, it shifts it up by 1. Okay. And so my picture of 1 plus square root of 9 minus x squared is going to be a semicircle that's been bumped up by 1 unit. So when I go to draw this, here's the center at 1. 1, 2, 3. We're going to go 3 units up. And so we've got this semicircle, top half of it's been shifted up by 1 unit.
So we still don't account for the bottom part at all?
That's right. So this bottom part is, that only comes from trying to understand what this picture is. With the with the y equals the positive square root,
Okay.
that means only the top half.
Okay.
The negative square root would be if we also had this guy, but we don't actually have that.
So that's telling us that it's a semicircle instead of a circle that
That's
we're
correct.
using?
Yep, that's right. And that makes sense because we want to have a function rather than this guy doesn't pass the vertical line test. So we would either have the positive or the negative, but not both.
Okay. So we won't have a circle because of the vertical line test?
That's right.
Okay.
That's right. So it's really a good idea to identify when you see something like square root of 9 minus x squared or square root of 1 minus x squared, that's probably going to be the top of a circle. Or if you have a negative in front, then it would be the bottom of a circle. So those are things that you'll see often. Okay, so now we've got, this is our picture of f of x is equal to 1 plus the square root of 9 minus x squared. And we are interested in the integral from -3 to 0 of this function. So our x values are starting at -3. So I'm going to draw a vertical line here at x equals -3, and also a vertical line here at x equals 0. And we are interested in the area under our function and above the x-axis. Okay, so that is our region we're looking at. And so this is all happening above the x-axis, so we don't have to worry about negative values here. So if we want to find that area that we have shaded, what can we do? What's that? Okay. Yeah, so pi r squared divided by 4. Now that pi r squared divided by 4 is going to give us the area just of this upper quarter circle.
It's okay.
Okay, so for that part, we've got pi r squared over 4, and our radius is 3 in this case, so we've got pi, or well, we can even just do it as 9 pi over 4 for that area. Okay. And that is strictly for that quarter circle up there. And then we also have this area, this rectangle down here. So for that one, we can do length times width. So the area for this little region, well, let's see, our height is 1, and our width is 3. So in that area, we have length times width, which is 1 times 3. And so to come up with the area of this total region, we actually had to break it up into 2 separate pieces, where 1 was a quarter circle, which we get by pi r squared over 4, and then the area of this rectangle down here. And so now we need to add them together. And so in the end, we've got that the integral from -3 up to 0 of 1 plus the square root of 9 minus x squared dx is equal to 9 pi over 4 plus 3. And as far as an exact value, that's the best I can do. If I wanted to come up with an approximate value, I could type in 3.14 for pi and evaluate that. But as an exact value, that's where I stop. All right, Aaron, does that answer your question? All right, other questions about number 33? Other practice problems?